number 3. Let's read the question first, right? Okay, given a geometric progression with a first term a and a common ratio r, where r between 0 and 1, r more than 0 and less than 1, not inclusive of 0 and 1, you have to proving is part of the syllabus, is in the exam syllabus. Alright, so we are going to prove this thing. Sum of the first 3n minus sum of the first 2n over Sn is equal to R2n. Bear in mind that the R here is very important. R is between 0 and 1 means R is less than 1. So we have two formula to use. Sn equal to A. If the R is more than 1, if R more than 1, we will choose R n minus 1 over R minus 1. This is meant for R more than 1. That means for the case here, we have to use the other formula, which is actually equivalent to Sn is equal to A is almost the same, but the 1 must be come first. 1 minus Rn over 1 minus R. This one is meant for R less than 1, which is fulfill the condition here. So we are going to use the red formula to prove. Right, we're going to prove this. So for proving, we always start from one side, left hand side, and then we will work, so show all the step, work to the right hand side. So we always start with the side which is more complicated. Alright, so let's try it now. We are going to start from the left hand side. So let's start with the left hand side, and then we show that we can get the answer in the right hand side. So left hand side, we are having S3n minus, this is sum for the first 3n, minus S2n, okay, over S3n minus S2n over Sn. This is asking by the question. So we are going to do until we get the right hand side, right? Okay, first of all, just now I mentioned to you the formula that we will use is Sn equal to A 1 minus Rn over 1 minus R, because due to R less than 1. Alright, so let's get started with the proving. So let's have a look at our question first. The question is this one, S3n minus S2n over Sn. Right, so let's go back to the working. Alright, we're going to start from left hand side, and we want to show that we can get the right hand side. Show the step clearly. So we are going to use this formula here. Let's do it together. I'm going to use a purple color pen to show you. So if sum for the first 3n term, we will just copy the formula. Here we will write 3n, right? Over 1 minus R. Okay, that is sum for the first 3n. Then we will minus sum for the first 2n is still the application of the formula. It's just that here is 2n, right? And then here is 1 minus R, and we are going to divide by Sn, which is this formula. So A 1 minus Rn over 1 minus R. Wow, it looks like very complicated. To prove S3n minus S2n over Sn, so let's start from left hand side. This is the left hand side. We're going to start from left hand side, and then we show we will get right hand side. So the formula for Sn for R less than 1 is 1 minus Rn over 1 minus R. So let's substitute carefully. 1 minus R. This one you have to substitute 3n. Alright? Okay. Over 1 minus r minus a 1 minus r over 1 minus r. So here you will substitute 2n. Right? We substitute 2n. 2n here. Right. So the down one we will divide by Sn. Sn here we will use a Sn formula. Let's use a Sn formula. Okay, so we are going to use the Sn formula, which is a 1 minus Rn over 1 minus r. Notice that this 1 minus r are the denominator, right? Okay, now we can simplify further like this. We can say a, this is a common factor. We factorize the common factor. Alright, we take out this a. Alright, actually we can join them. It becomes r 3n minus 1 plus r2n. Be careful, this is minus, right? So a we factorize it. This is 1 minus r, the denominator. We can join them, and this one is means dy. Alright, so we can write dy. When we divide, we will divide by a 1 minus rn over 1 minus r. Notice that when you divide, you can inverse. This one cancel out already. It becomes very simple, right? And 1 minus r, this one you must make it multiply because you divide. This is divide, so you have to inverse like this, right? Okay, now we can cancel out this thing. We can cancel out the common factor. Finally, we almost reach the answer. We have r2n and negative r, so we can factorize the r2n. So if I'm going to get negative r3n, isn't it I would have n here? This is plus 1 because you factorize it, you have to divide. Alright, and then the down part left only this thing, 1 minus rn. Notice that this one is the same with this one. Is the same. This is 1 minus rn. Same. So we can cancel out. So finally we prove that we will get r2n. So we say proven because we get the answer same as the right hand side by showing all the step clearly. We show the step clearly. Okay, so show the step clearly so that people can understand what are you doing. Right, so just use a formula and choose the right formula to use. The formula that you choose must be r less than 1. Alright, that's all my sharing on how to prove the sum for the first n term formula with the condition given by the question. Alright, till then, bye bye and have a nice day.